Alrighty, I'm going to continue solving the sample or practice exam, what they call as a practice exam, the College Board. This is actually written by the College Board. Practice multiple choice. We left off on number 22 in the no calculated portion. So let's continue. The increasing function p, so maybe it's key that's increasing, so let's underline it. Increasing function p gives the following number of followers in thousands for a new musical group on a social media site. The table gives values of p of t for selected values of t in months since the musical group created their account on the social media site. If a model is constructed to represent these data, which of the following best applies to this situation? All right, so let's look. A and B are linear, C and D are exponential. This is exponential decay. Why do I know that? Well, the term that's being exponentiated is less than 1. So it's going to look something like this. Well, over here, this is exponential growth because the term being exponentiated is greater than 1. So it's going to look something like that. And as I said, these two are linear. So is it linear? If it's linear, there should be a constant change as we keep going, because this is in the same interval. The month is always increasing by 1. So if it's linear, the change should be the same every month. This is a change of 10, this is 15, this is more than 15, this is way more than 15. So clearly it's not linear. Eliminate those. Now, and then just by seeing that it's growing, we can eliminate it's not exponential decay. This one. So it answers D, as simple as that. Okay, so the key here was you should be able to identify this was a decay, this was a growth, and you can see it's growing, so it's D, and clearly it's not linear, as I explained. Polynomial function k is given by this guy, where a and b are non-zero real constants. Each of the zeros of k has multiplicity 1. In the xy plane, the x-intercept of the graph of k is this guy. A zero of k is this complex number. Which the following must be true? Okay, so when we have a polynomial of degree 4, we know that there are 4 roots total. Okay, that's probably key. And then since there is a 0 that is complex, remember there's a 0 that's the complex conjugates of it. So there's going to be a 0 at minus 0.478 plus 0.801i. Okay, so that takes care of 2 zeros already. And this is a real 0. Okay, each 0 of k has multiplicity of 1. This says real, by the way. Okay, so there's going to be one more real 0. Okay, so let's see what the choices say. Graph of k has 3 x-intercepts. No, it's going to be 2 because there's going to be, as I said, one more real. There's 2 complex, which aren't, the graph's not going to touch the x-axis at complex values. Only at real values it will. So it should not be A. Okay. This is exactly what I said, actually. This is a 0 of k because it's a complex conjugate. So it's probably B. But let's look at the other choices. Equation k of x has 4 real solutions. No, they already give us a complex one. And we said that it's 4 roots total. And there's one complex already, so no. Graph of k is tangent to the x-axis at this. It's not tangent. It crosses because it's an intercept. Or actually, not true. It could be tangent because if it has multiplicity of 2, then it would be tangent. When there's a repeated 0, it doesn't cross the x-axis, if you remember that. Okay, but since we are told that it has multiplicity 1, then it cannot be repeated. So it has to cross the x-axis at that point, so it won't be tangent. So the answer is B. All right, hopefully that was helpful that I explained all the choices and why those 3 were wrong and this one was the right answer because complex conjugates. Consider the functions f and g given by f is log x minus 1 plus log x plus 3, and g is log x plus 9. In the xy plane, what are all x coordinates of the points of intersection of the graphs of f and g? Okay, so points of intersection, we have to set f equal to g. Okay, so what's f? Log, I'm going to eliminate the base 10, x minus 1 plus log x plus 3 is equal to log x plus 9. How the heck did we solve this? Well, we can combine these two logs, properties of logs. When we have a sum of two different logs, we can, same base, we can multiply the arguments. So it'll be x squared plus 2x minus 3. Okay, so maybe I should write it like this. So one more step in the middle. I'm going to insert one step in the middle over here. Okay, so it'll be log of x minus 1, x plus 3, okay, is equal to this. So then that's how I combined or expanded the x minus 1, x plus 3. That's how I directly went to here. Okay, so this is the same thing as this by properties of logs. So then, yeah, I expanded it. Okay, so now we can exponentiate both sides. So 10 to the log x squared plus 2x minus 3 equals 10 to the log x plus 9. So 10 to the power and log are inverses. So we get x squared plus 2x minus 3 is equal to x plus 9. Now we can solve for x. Okay, so it would be x squared plus x minus 6 is equal to 0. So if we factor it, it'll be x plus 3, x minus 2 is equal to 0. So our solutions are x's minus 3 and 2. Okay? Now, oh, actually, no, I did not do this right because it'll be minus 9 here. So it would be minus 12, sorry. And this would be, let me redo it from here. Okay, so it would be, if we factor it once again, it'll be x minus 3, x plus 4 is equal to 0. Okay, so x is 3 and negative 4. Okay, so that looks like C, but let's just double check if it's not A, because let's check the domain. If x is 3, we have log of 2, which is fine. Here we have log of 9, which is fine. Here we have log of 12, which is fine. Okay? If x is negative 4, this would not work. Log of a negative number. Okay? So we cannot have x is negative 4. It's not in the domain of f. So it'll actually be A. And that's correct. I just checked the key. Okay? So that was the key here. So I was suspicious already. Like, why did it give this? Well, you had to check the domain. That was why. Because when x is negative 4, this log over here would be undefined. So it's A in this case. Okay, and sorry for the small algebra error, simple math error even over there. Okay, I was able to catch it because I didn't see any like 2 over here. So that's how I noticed I did something wrong. Okay. Let's see if I can finish all these problems in this video. It might be a little longer, but that's okay. So let me even take a brief intermission right now to ask you guys to like and subscribe if you have not already, if this video has been helpful for you so far. Okay, let's continue. What are all values of theta, theta is between 0 and 2 pi, where 2 sine squared theta is minus sine theta? So how do we solve this trig equation? Let's set it equal to 0. That's the way to go about it. So 2 sine squared theta plus sine theta is equal to 0. So now let's factor sine theta out. So it'll be 2 sine theta plus 1 is equal to 0. Okay, so we have two cases where sine theta can equal to 0 to make the equation work, or 2 sine theta plus 1 is equal to 0 to make the equation work. Okay, So let's solve on both branches between 0 and 2 pi. So this theta would be 0 and pi. Okay, that one's the easy one. All right, so how about this one? It would be sine theta is equal to minus half. So where does that happen? So you want the y, sine is the y in the unit circle, if you remember. So you want the y value to be negative. So it'll be somewhere here and somewhere here. Okay, so this one is the easier one for me to do right away. I know that this one would be 11 pi over 6. Okay, because I know that sine of negative pi over 6 would be negative half. This is the same thing as negative pi over 6. So I just add 2 pi to it, swing it into this domain of theta. So negative pi over 6 plus 2 pi, that's 11 pi over 6. Over here, it would be pi plus another pi over 6. So that would be 7 pi over 6. So our theta would be 7 pi over 6 and 11 pi over 6. Okay, so that looks like it is B. And that's right. Okay, so that's how you solve this one. It was a pretty basic solving the trig function for its zeros. Oh, there's a polar curve. Let's see. Figure shows the graph of the polar function r is f of theta, where f of theta is 4 cosine 2 theta in the polar coordinate system for theta is between 0 and 2 pi. There are 5 points labeled as A, B, C, D, E. If the domain of f is restricted to theta is between 0 and pi over 2, the portion of the graph given of the given graph that remains consists of 2 pieces. One of those pieces is the portion of the graph in quadrant 1 from C to E, which the following describes the other remaining piece. Okay, so if it's from 0 to pi over 2, it's saying that one portion is from C to E. Okay, so obviously when we start from theta is 0, the cosine of f would be 4 times cosine of 0, which is 4 times 1, which is 1, so 0 would be here. And then when we get to over here, hopefully you can kind of guess that that would be when the cosine is 0. So that would be when cosine, when 2 theta, so E1 2 theta is equal to pi over 2. That's when cosine of pi over 2, that's when it's 0. So theta would be pi over 4. Okay, so maybe we could even just plug in when theta is pi over 2. So f of pi over 2 would be 4 cosine of pi, because 2 times pi over 2 is pi. Cosine of pi is negative 1, so it would be minus 4. So the portion would be from E to A then. Okay? Actually, that's not right. My bad. Okay, so when the angle is pi over 2, so pi over 2 is here, r is negative 4, so we go in the other way. So it'll be E to D actually. Totally my bad. I immediately jumped because I saw negative 4. It will be here. No, that's not right. We had to consider this angle pi over 2. So once again, when it's pi over 2, it's pointing up here. The r is negative though. So negative 4 instead of r is 4, it will be opposite. So negative 4 down here. So it'll be E to D. So it should be D. Let me double check if that's the answer. Yes. Good. Okay. So don't jump too quickly like I almost did. Okay. Moving on. 2 more. Maybe something in the back of this paper so it writes along nicer also. Okay. Physical Therapy Center has a bicycle that patients use for exercise. The height in inches of the bicycle pedal above level ground periodically increases and decreases when used. The graph gives the position of the pedal P at a height of 12 inches above the ground at time t is 0. The pedal's 8-inch arm defines the circular motion of the pedal. If a patient pedals 1 revolution per second, which of the following could be an expression of h of t, the height in inches of the bicycle pedal above the level ground at time t seconds. Okay. So let's pick out the key points. 1 revolution per second, that should signal the period of the sinusoid. So the period, if we call it capital T, is 1. Because after 1 second, you're back to the same position. So that's the period. Okay? When we have sine of omega t or cosine of omega t, the period, capital T, is 2 pi over omega. Okay, so this is equal to 2 pi over omega. So omega would be 2 pi. So we can already eliminate A and B. All right, now, at time 0, it starts at 12 inches. Okay, so we can plug in t is 0 into both of these. When t is 0 here, sine of 0 is 0, so we're left with 8, which is not 12. Cross that out. Plug in t is 0 here, sine of 0 once again is 0, we'll start with 12. So that's correct. Answer is D. As simple as that. Last one. Graph of the polar function r is f of theta, where f of theta is 1 plus 2 sine theta in the polar coordinate system for theta is between 0 and 2 pi, which the following statement is true about the distance between the point with polar coordinates f of theta and the origin. Okay, so the distance is increasing or decreasing from some interval, okay? So, maybe let's just go, well, the intervals are the same for AC and BD, so let's go from 0 to 2 pi. From 0 to 2 pi, we know that sine theta is increasing. Remember how sine looks, the function sine theta looks something like this. Okay, so this would be at pi over 2. Obviously, that would be at 0. So between 0 and pi over 2, the sine function is increasing. So f would be getting bigger. So that means the point P, or did it say P? So the point with respect to origin is getting further. In polar coordinates, r is the radius, right? And r is f of theta, so when this guy increases, it gets further. So it should be increasing, so we can already eliminate C. And similarly, from 3 pi over 2 to 11 pi over 6, so this is 3 pi over 2. 11 pi over 6 will be somewhere here. 11 pi over 6 is just short of 2 pi. This is a little small, hopefully. It's a little messier now, but 11 pi over 6 is somewhere there. 3 pi over 2 is right here. Okay. So over here, it's negative, but it's getting less negative. Okay? So that also means that our f is going to be, well, this term, since it's negative, and it's getting less negative, so it'll make the radius get, it'll be, actually, you got to think of it a little differently here. So this is negative over here. Okay? So this already would be negative 1 plus 2 sine theta. Okay? At 3 pi over 2, sine of 3 pi over 2 is minus 1. So it'll be 1 minus 2, which is minus 1. So as you get less negative, then it'll actually get closer to the origin then. Okay? So that means it's getting closer, so distance would be decreasing. So we can eliminate B then. Okay, so now we're left with A and D. I might not be doing this the quickest way, but this is how I'm thinking through it. Okay, now let's look at the reason. Because F is positive and increasing on the interval, That's exactly what we're saying. It's positive and increasing, so that distance is going to be increasing. How about here? Distance is decreasing because f is negative and decreasing. F is actually increasing, as I drew over here. So it's not D. Answer is A. Okay, and that's it for the no calculated portion of the multiple choice in this practice exam. Hopefully this has been helpful, whether you just watched this episode or any of the previous episodes. Please like this video once again if you found it helpful in any way. And please subscribe also to get notified of when I start solving the calculator required portion. So hopefully I'll see you in that video.